In this question, we have the definite integral of t to the 6 minus t squared divided by t to the 4. Let us go back to algebra and simplify this guy first. So first of all, in algebra, we know that if you have a minus b divided by c, we can write this as a over c minus b over c. So this quantity, which is t to power 6 minus t squared divided by t to the 4th, can be written as t to the 6th divided by t to the 4th minus t squared divided by t to power 4. Now you can just simplify this as much as you can, because here you have t to power 6 times t to power negative 4 minus t squared times t to power negative 4. And please pay attention here. I moved t to the 4 to the numerator. That's how it got a negative exponent. So between these two, if you write one base and combine the numerators, 6 minus 4, which is 2, minus between these two, take the common denominator t, and you get 2 minus 4, which is negative 2. So take this guy and substitute that for the quantity that you have inside your integral. So your integral becomes 1 to 2 of t squared minus t to power negative 2 dt. Remember that we learned if we have the integral of x to power n dx, it is x to power n plus 1 over n plus 1 plus constant of integration. It doesn't matter if n is negative or positive. You have the same rule to follow. The very first integral becomes t cubed divided by 3, and your t is ranging between 1 to 2, minus the second integral. Remember that if you have the integral of t to power negative 2 dt or x to power negative 2 dx, it becomes x to power negative 2 plus 1 divided by negative 2 plus 1 plus c. In short form, you can write it as x to power negative 1 divided by negative 1 plus c, or negative 1 over x plus constant of integration. So let me change this to x to have a general formula to follow. This is exactly the same for t here. Minus negative 1 divided by t, and your net t ranging between 1 to 2. So if you plug in 2, you get 8 divided by 3 minus 1 over 3 minus. So you can combine these two negative signs before entering 2 and 1. So it becomes positive plus. You get a half minus 1 over 1. So you have 7 divided by 3 minus, here, if you combine this together, you get negative a half. So you have 6 as the common denominator, 14 minus 3, or 11 over 6 as the final answer for this definite integral. Another integral of this form can be written as the definite integral of x squared plus 1 divided by square root of x, x ranging from 1 to 2. Again, from your algebra, if you have a plus b divided by c, it is a over c plus b over c. So if you take this quantity, which is x squared plus 1, and divide it by square root of x, this is nothing but x squared divided by square root of x plus 1 over square root of x. Well, this can be written as x squared divided by square root of x is x to power a half plus 1 divided by x to power a half. These are all algebra, right? Square root of x and x to power a half are the same thing. Now, this can be written as x to power 2 times x to power negative a half plus 1 times x to power negative a half. If you combine these two, you have x to power 2 minus a half plus 1 times x to power negative a half, which is written as it is. So this can be written as x to power. If you take common denominator, you get 3 halves plus x to power negative a half. You can do the substitution. For the integral that you're having here, you can just use the substitution using this simplified expression. So your integral is now the integral 1 to 2 of x to power 3 halves plus x to power negative a half dx. And since these two are different objects, you cannot combine them together. Perfect. So let us go back to the integral of x to power n dx, which is x to power n plus 1 divided by n plus 1 plus constant of integration, and do the calculation, everyone. This can be written as x to power 3 halves plus 1 divided by 3 halves plus 1, as x is ranging between 1 to 2, plus x to power negative a half plus 1 divided by negative a half plus 1, as x is ranging between 1 to 2. Let us rewrite this in more simplified form. You have x to power 5 over 2 divided by 5 over 2. X is ranging between 1 to 2. And here you have plus x to power a half divided by a half, 1 to 2. Very good. So this guy can be written as 2/5, and then plug in 2. You get 2 to power 5 over 2, plug in 1, negative 1 to power 5 over 2, close the bracket, plus 2 bracket 2 to power a half minus 1 to a half. Okay, let me move this a little bit here. So you don't get confused by this equality. This equality belongs to this guy up here. It has nothing to do with what we did here. Okay. So you can write it as 2/5, and this guy is just the square root of 2 to the 5th minus 1 plus 2 times square root of 2 minus 1. From algebra, square root of 2 to the 5th is basically the square root of 2 times 2 to the 4th, or the square root of 2 times 16, or square root of 2 times square root of 16, or 4 times square root of 2. So this guy can be written as 4 times square root of 2. We're trying to simplify it as much as we can. So you get 2 over 5, 4 square root of 2 minus 1, plus, if you distribute this into parentheses, get 2 times square root of 2 minus 2. So now distribute 2/5 into parentheses and try your best to simplify as much as you can. You get 8 over 5 times square root of 2 minus 2 over 5 plus 2 times square root of 2 minus 2. Well, you can combine these radicals and you can combine the constants in terms. If you take common denominator between these two, you have 18 over 5 times square root of 2, and you get negative 12 over 5. You can leave it as it is, or you can write it in more simplified version as well. If you factor out 6 over 5, we get 3 square root of 2 minus 2. A lot of algebra, but it's a good practice to feel comfortable about these types of integrals.